What we're going to go over in this video is taking a monomial and raising it to a power. Taking a monomial and raising it to the second power, or the third power, or the fourth power. When you take a monomial and raise it to a power, you have the monomial inside parentheses, and on the outside of the parentheses there's an exponent. That exponent tells you how many times you're multiplying that monomial to itself. Here's an example. I take what's inside the parentheses and I write it down that many times. That's how many times I'm going to multiply it to itself. So that's 2x to the fourth times 2x to the fourth. And then I remember my rules for multiplying monomials together. I multiply my coefficients. 2 times 2 is 4. I write down the variable I'm using, and then I add my exponents. 4 plus 4 is 8. So let's try this again. I'm going to take this monomial inside here and I'm going to raise it to this power. That means I'm going to take 2m to the second n and multiply it to 2m to the second n and multiply it to 2m to the second n. Again, I need to multiply all these coefficients together. 2 times 2 is 4, times 2 is 8. I write down the first variable I'm using, m. What do I do with these exponents when I multiply? I add. I go 2 plus 2 plus 2 is 6. I need to add the exponents on these ends. Remember, there's a 1 right here, a 1 right here, and a 1 right there. If I add all those 1's up. Now what we need to remember about this is if you're adding the same number over and over and over again, what are you really using? If I'm adding the same number over and over and over again, I'm just using multiplication. So what I'm going to show you next is a rule that we can use in these situations like this. This is going to be the only time that you can multiply exponents, because instead of adding the same number over and over and over again, I can multiply. Here's the situation that I'm talking about. Instead of me writing x to the third 20 times, think about that. I'm going to write x to the third 20 times and adding those 3's over and over and over again. A quicker way of doing this would be to multiply the exponent on the outside to the exponent on the inside. And when I do that, I get x to the 60th power. If I wrote out x to the third 20 times and added those all together, I would get x to the 60th power. So, the shortcut on this is this. If there's an exponent on the outside of the parentheses, this is the only situation where you can multiply it to the exponents on the inside of the parentheses. Another thing that you need to remember, this only works with monomials as well. So let me say this again. When you've got a monomial inside the parentheses, you can take the exponent on the outside of the parentheses and multiply it to the exponents on the inside of the parentheses. And remember, this only works with monomials. So let's try another one. Instead of me writing this 3 times, I'm going to use this multiplication rule. That means I'm going to take the exponent on the outside of the parentheses and multiply it to the exponent on the inside of the parentheses. That's going to give me y to the 12th power, because 3 times 4 is 12. What exponent is on this x? Remember, there's a 1 sitting there. We don't see it. 3 times 1, x to the 3rd power. Not only do variables have exponents, numbers have exponents as well. Well, what kind of exponent is on this 2? Just like this variable, there is a 1 sitting there that you can't see. And this 3 needs to be multiplied to that exponent as well. 2 to the 3rd power. So 3 times 4 is 12. 3 times that 1 there is 3. And 3 times that 1 there is 3. Looking at what I have here, one of these I can actually do some more math. One of these I can actually raise to the 3rd power, and I know what it is. That would be this part right here. I actually need to figure out what 2 times 2 times 2 is and write that coefficient down in the front. 2 times 2 is 4, times 2 is 8. 8 x to the third y to the 12th. Let's try this rule again. This rule tells us this. If I have a monomial inside parentheses and there's an exponent on the outside of the parentheses, I can take that exponent on the outside and multiply it to exponents on the inside. Each part has an exponent. That 10 also has an exponent, and it has an exponent of 1. 3 times 1 is 10 to the third power. 3 times 7 is t to the 21st power. And then I need to multiply these numbers out and get my coefficient that goes in the front. That would be 10 times 10 times 10. 10 times 10 is 100, times 10, 1,000. T to the 21st power. One more example. If there are parentheses and an exponent on the outside of the parentheses, and this is a monomial, then I can use this rule. The rule tells me I can take the exponent that's on the outside of the parentheses and multiply it to the exponents that are on the inside of the parentheses. A good thing to do, I can see these exponents, and I need to write exponents on these other numbers where I can see them, so I can make sure that I'm multiplying those numbers together. 2 times 1, 8 to the second power. 2 times 1, x to the second power. 2 times 3, y to the 6th power. 2 times 4, z to the 8th power. 8 to the second power is 64, and then I write the rest of them down. This rule only works if there's a monomial on the inside.